So this is a video that's going to review the Pascal and Wheaton 4-quadrant model, otherwise known as the 4QM model. And so I just want to go over it again in case you had any questions about it. And so there's 4 quadrants in here. And so again, before I get into what it does, I needed to motivate why it exists. And so basically, it's going to be able to trace out dynamics in the real estate system. So the slide that we had, where we had the real estate system, that was a static model. What the 4QM model is able to trace out what kind of changes do we experience in the other sectors, given that there's a shock in one of these 4 quadrants. All right. So a few things about the model. Number one, it does assume that you can only have one shock in one quadrant. So you can't. You're going to have one change in one quadrant, and then it's going to that change is going to trace out in all the other quadrants. But you can't have one, say, here and then another shock here. It's not able to do that. And number two is that we don't know how much time that goes through here. But again, this is a theoretical model, and so the underlying theory behind these changes is there and it's solid. It's just that we don't know exactly how much time it is. Different markets would take different times to adjust. Okay, so we start out. It's best to go ahead and start off here and talk about the space market. So in this quadrant, this is where rent's determined. So given a certain level of existing square footage of space is Q star. So everything that's star means that we're in short-term equilibrium, and it forms a perfect rectangle. So everything's nice and in balance. But given this certain level of existing space and given this demand function, we're just going to start from here, from our supply, then hit to our demand and draw over here. And so at this level of, given this quantity of space, we have this level of demand generates this much in rent. And so we see rent is up here, all right? So this is where rent's determined, and so this gives us our equilibrium rent, all right? So that's the space market. Remember, users of space and people who own the space, and then people who are tenants that are looking for space, those interact, the supply and demand interacts, and then rents are determined. All right, so the next one is the asset value market valuation quadrant. And so rents, we're going to come over here to this line, and this line is the cap rate line. Okay, and we'll see that income, the value of the income of property, is a function of its income, the income it produces, and the cap rate. So it's NOI, net operating income, divided by cap rate. So the larger this number is, the lower value is. So if I want to draw larger, an increase in cap rates, I draw the line more like this at a higher slope. If I want to decrease cap rates, I draw like this at a lower slope. Okay, but sorry about that. So rents, values when we determine, so rents where they hit the cap rate line, and that's going to give us value. It says price, but you can equate price and value as the same thing. Okay, so again, valuation market, the product is value. All right, so what happens over here in the construction market? Well, the lines here, this is going to be your variable construction cost, and this reason why it doesn't join in at the origin here is because this is like an intercept term, and so this is going to represent fixed development cost. This is marginal development costs, right? And so we just draw the line from value, and we know that profit maximization occurs when marginal revenue equals marginal cost. So we can think of this price as your marginal revenue, and this variable cost as being your marginal cost. So just draw the line till it hits this line and draw it over, okay? So that's the construction market, right? And so this last one is the stock adjustment. This just means that when we construct and add space, that we draw this over to this line and draw up, then the difference between where we started this Q star and our new space, that would tell you the amount of construction. So as you add space, you're going to come out here. As you decrease space, you're out here. And again, the reason why we can decrease space is usually we're not going to go demolish things, buildings, just because the values have gone down, but rather some buildings are just going to depreciate over time, and we're just not going to replace those. So that's how we can have loss of space. Also, we can have a natural disaster that wipes out space, and then if we don't go back and reconstruct those things, rebuild on those sites, then we would have a loss of space. Okay, So that's kind of the setup of the model. And so the book provides a specific example of what would happen when we had, if we were to have a sudden shock in demand growth. And so the example that we work in class is, what if all the school systems, all the university systems in North Carolina shut down, and Charlotte was the only, they announced because of budget cuts, and that UNC Charlotte was the only campus that was going to be operating. We would expect to see a sudden demand shift, right? So it was totally unexpected on change, and so, but we see a demand shift, we increased from here, from D0 to D1 here, all right? So that's from on. So to trace this out, what you're going to do is start at the beginning of your quadrant and just go up into the new line. And so the next graph actually does that a little bit neater for us. All right, so we see go from here, it draws up to there, and then it's going to go over there and stop here, and that's our rent. Okay, so given an increase in demand, holding constant the quantity of space, that impact would be an increase in rents, which makes sense. All right, so let's what happens on the valuation market. So as it shows, you draw your new rent line over here to that cap rate. Remember, so the cap rate's been changed. Remember, we only have one change. This is our change right here. Everything else is held constant. So we're just going to draw this line and go down like that. And so this gives us our new price. So given a increase in demand, which generate holding constant quantity, that's going to increase rents, which holding constant your cap rate is going to increase prices. Right? So going down to the asset construction, this line is going to be continuing to go down, and it's really supposed to hit this line. So just kind of pretend that this line keeps on going here, and it hits it and is drawn over. All right. And so what this is going to say is, because values are higher than their cost, then we're going to expect the fixed cost and then the marginal cost. It's going to be profitable to develop. So we did stop where marginal costs were here. But again, marginal revenue equals marginal cost. That's going to be your profit maximization. You're going to keep on building until those marginal costs get out to be about right here. Again, the graph just doesn't meet very well. And so you're going to draw this over to this line, the space adjustment line, again, just to pretend like this line comes all the way out. And so it's going to come right here, and then you're going to draw that line back up to here. And we see that this is not going to be a long-run equilibrium result, because it doesn't form a rectangle. Okay, so you see that the short run, it was a perfect rectangle, but in this one, these sides don't connect. Okay, so what this means is that it can't be a long-run equilibrium, but all these changes happen, right? So the rent increased, and that led to value increases, and we had construction increase, activity increase, and that ultimately led to increase in stock. But because this thing goes around again and keeps going around again, this was, we added space, but guess what? Now that the space is starting to be absorbed, all those things happen, but not as much as they did. So I think that, you just draw this new long-run equilibrium in between where you were and where you aligned. So if you're drawing this long-run equilibrium, you might draw it kind of like this, just kind of halfway in between, just make sure it's a perfect rectangle, right? And so that's what you get. That's what you're getting from this slide. They just kind of drew it about halfway in. So what this means is that yes, rents increased, but not by as much as people thought in the long run, because that new supply got added right here, right? And so long run, those rents would come back down some. So it's kind of an overreaction. So the same thing happened with price. Prices increased to this point right here, but then in the long run, they came back because, again, that was kind of an overreaction. And then you see the same story going all the way across, okay? So in summary, in this example of this was our big change here, the increase in demand, holding everything else constant, we would see an increase in rents, an increase in asset values, an increase in construction cost, construction activity, and then an increase in square feet, space added. And that would be what you would get at. So you can use the same model to trace out, what would happen if there was a decrease in demand. And so you'd be like that. You can do it to show what would look like if there's a increase in cap rates or a decrease in cap rates, or if the marginal, or if the development costs decrease, you can just draw this line, kind of like this, all right? Because so that would be, decrease both your fixed cost and your marginal cost. The only shock you can have here is if there's a sudden decrease in space. And so you would just start off here and just say, okay, this is, excuse me, don't do that. But what I would have done is, if this is where equilibrium, I would have drawn it inside the equilibrium, short run equilibrium, and say, okay, we did have the space here, but now we have space here, and just draw this up, all right? And then that would say, okay, we've lost space between here to here. And if we lose space holding constant demand, that's going to lead to an increase in rents, and then you continue to trace that out. Okay, it's important to note that in each quadrant, whatever quadrant you change, you want to start your drawing at the beginning of that quadrant. So in this case, we increased demand, we started our quadrant, started the changes right here. Went up from this part to here. In this next example, they're going to increase they're going to decrease the cap rates. So holding everything else at constant, cap rates decrease, and we want to know the effect of that, right? So to do that, you're going to start here at this level right here at the rents, and draw it to your new cap rate line, and draw on across till you hit all these lines, and going back here. And so you see that long run, that's not what happens. These changes occur, prices do increase, but not as much as we thought. Construction activity increases, but not as much as we thought. And then finally, because there's a decrease in rents, ultimately, hopefully that makes sense, because your demand is being held constant, right? So now we've added supply just because cap rates have decreased, which makes the properties more valuable, which makes it profitable to develop. But once that space gets added on, rents are going to decrease because there was no corresponding increase in demand. And so ultimately rents go down. And so that means that values wouldn't go up as much as they thought. So that's why the long run response, it comes back somewhere between where we started out with and where they initially grew out to. There's somewhere in between those two lands, okay? And so you can do the same thing with these other quadrants. So again, hopefully this has been helpful for your understanding the 4-quadrant model. There's lots of resources on the web if you need additional help. But hope this was helpful to you guys, and thanks for watching.